Okay, we are back to discuss on part of the limit equilibrium analysis for single layer key points. So after this, you can see how the analysis was carried out for the chosen case study. So first of all, is a failure mechanism. For this kind of the failure mechanism, you're going to see there are few failure mechanism highlighted by the previous researchers. For this problem, there will be around 2 failure mechanism type. And the analysis will be carried out using the limit equilibrium analysis. So currently, kenapa limit equilibrium analysis dia tidak lagi menjadi satu method yang diguna pakai kebanyakan analysis untuk solve a problem, because some the LEM dia ada beberapa limitation. Therefore, they go to the advanced method such as finite element method ataupun finite difference method or any other numerical method. For example here, for the failure mechanism, in the limit equilibrium analysis, the soil is assumed to fail along a certain failure mechanism or failure surface. After this, you will see the definitions or the statement mentioned here. What is the meaning of the certain failure mechanism? For example, if a single layer soil, the failure surface is typically assumed to be a shape, which is often a simple geometric form like a wedge or slip circle, along which the soil would start to eat and fail. The next is equilibrium considerations. So the analysis consider the equilibrium of forces and moment acting on the soil mass. So the driving forces that tend to cause failure, for example, apply load and the weight of the soil, are compared to the resisting forces which along the assumed failure surface. So this application or something that can be seen easily kalau you have some kind of the slope problem lah. Sebab bila slope problem, kita ada satu slip circle, satu force adalah shear strength, the other force as a shear stress. So these two forces dia dalam keadaan equilibrium. Satu dia try resist, satu lagi dia try melawan. So kalau kata resistant force tu kecil, automatically slope failure akan berlaku. Tapi kalau kata resistant force besar, disturbing force tu kecil, so failure tu takkan berlaku lah. So the same thing concept applied for bearing capacity lah. So the factor of safety kalau tengok kat sini is into the definitions just now. Factor of safety kalau ikut application selalunya berbeza lah. For example, kalau kita analyse for the bearing capacity, most of the time kita can choose the factor of safety around 2.5 to 3.0. If you have a kind geotechnical application yang lain, contohnya slope stability, so kita boleh letak dia sebagai 1. So if you have FOS more than 1, we can consider that our calculation or FOS is or the structure is safe. Tapi kalau kata you calculate FOS tak dapat lagi 1, maknanya you have to recalculate until you can get the right one. So limit equilibrium analysis, kalau you masuk dalam slope stability, there's something that you have to find the critical slip circle point. So the theta, the angle, until you can get the minimum FOS, that is the critical one. Tapi kalau kata you design slope you masih lagi dapat nilai 1.0, maknanya you tak dapat yang the right point that produce to the slope failure. So you have to redo again and redo again. So that is become iterative and repetitive process. Tapi kalau you guna finite element method, for example in the Plaxis, dia ada satu simple, we call it shear strength reduction technique. So bila you guna shear strength reduction technique ni, dia macam satu factorize, dia dah ratio kan, you run the analysis, dia dah boleh produce to you the failure or the critical FOS for that design slope. So same thing kalau application dia adalah bearing capacity. Okay, the next key concept about the limit equilibrium analysis is the iterative process. So it is often an iterative process where the assumed failure surface is adjusted until equilibrium is achieved and acceptable factor of safety is obtained. So this is we call as a iterative process. Kalau you tak dapat lagi dua benda ni, you have to redo and again and again. So this involves checking different potential failure surface until the most critical one is identified. So the next important parameters is the shear strength. So dalam case soil mechanic ni, kalau kata a bit orang kata konsep yang selalu kita nak pegang dalam soil mechanics ni is part of the mechanical properties, or we call it as a mechanical parameters lah. Mechanical parameters memang penting untuk ensure the stability of any geotechnical structure, sama ada embankment ke, bearing capacity ke, ataupun slope stability. So people will ask you, okay, what is the shear strength? And then kalau you're talking about this case, our problem is a undrained clay, so mostly kita nak tahu nilai C dia berapa, cohesion dia berapa. So kalau cohesion dia 10, what's indication meaning? Kalau 20, 30 for different clay type, for example city clay ke, purely clay ke, so they will give you different value of cohesions. So the shear strength parameters can be obtained from in situ testing ataupun you boleh buat daripada experimental work. In situ testing ni lebih bagus ni sebab kita boleh dapat undisturbed shear strength lah, CU undrained and then juga undisturbed shear strength. Tapi costly sikit lah. Okay, now we go to the failure mechanism. So as I told you just now, so untuk failure mechanism ni kita ada dua jenis, satu Brandel dan satu lagi simple scoop. So kalau the first figure as based on the Brand this theory, so the failure shape, this is what we can have, the triangle below the footing, and then the fan shapes at the right sides of the footing around 45 degree, and this is the undrained cohesion CU, and this something showing to you the failure mechanism according to this formula. Kalau you ada simple scoop, so the simple scoop given to you different slip circle of the problem. For example here, kalau you tengok sini, the mechanism of two rigid triangle blocks and a fan shear zone, that's referred to the simple scoop. So the simple scoop here is totally different because alpha ni kita tak tahu nilai dia berapa. Tapi kalau you tengok branded failure mechanism ni, dia dah specify dah the angle of the failure is 45 degree. So it is straightforward. So bila something that straightforward, so we might have some limitations lah, maknanya disadvantages. So kalau kata kita ada failure mechanism dia yang not fixed ataupun it can be adjusted according to the ultimate bearing capacity dan juga additional load, so yang tu lebih specify lah, ataupun kita boleh kata dia lebih accurate. So the other theoretical behind of this analysis, first you need to understand the upper bound theorem of the limit analysis for bearing capacity problem produced by Drucker et.al. So Drucker et.al. ni is actually try to introduce to you the behavior of the material. So it says that for the upper bound theorem of the limit analysis, the soil behave as this one. So dia more likely simple problem lah. Ataupun kalau the plastic deformations is only governed by Tresca yield criterion, which is untrue for real problem of the soil. So selalunya kalau kita model the behavior of soil failure ni, the simple soil model commonly known as a Moore column model ataupun linear elastic perfectly plastic. So the linear elastic perfectly plastic selalunya dia akan give to you the parameters that stand to the stiffness, yang mana zone yang lain ataupun plastic deformation can give to you the strength parameters. So when we come together, the elastic linear perfectly plastic, so the material failure can be predicted by defining the 5 parameters of the soil model. But this case, for the upper bound limit analysis, they only assume that the plastic condition fulfill to the Tresca yield criterion. So the yield functions that accept to this as seen from this figure at the bottom. So you boleh nampak lah how Tresca assume, let's say kalau kita ada few principal stresses or acting to the stress point, so sigma y, and then also in the two dimensions, sigma 2, sigma 1, and this is the shear stress, sigma y is the shear stress. So this is the simple assumptions made on the plastic deformations for upper bound theorem analysis. So the Tresca criterion is that of critical value of the maximum shear stress in the isotropic material. Maknanya kalau dia nak dapatkan shear stress of the failure soil ni, this is the point dia. Maknanya dia ambil the maximum shear stress on the y-axis. So kalau kita tengok on the yield function, this is that can be seen on the Tresca yield criterion for the problem. If we choose the failure mechanism as a kinematically admissible failure, when surface load is larger than the true collapse load or the best case equal to it, which causing to the failure. And the upper bound limit analysis works considered much simple, as can be seen in the figure 4.5b, with the radius r and the center of rotation O located over the footing edge. So this is what they say. Kalau you buat perbandingan the first branded failure mechanism and then juga simple scope failure mechanism, this is more applicable lah. Because dia ada some surface load action that acting to the soil. How to find surface load according to the scope mechanism? So these are some calculations and also formulations to develop the ultimate bearing capacity according to the failure mechanism for scope, which we trying to find the surface load or ultimate bearing capacity. So assuming that the work of the surface load on this small rotation can be then calculated as a product of forces and the corresponding displacement as the equation 4.1. So this is the W, the work of the surface load acting to the soil. Then from the previous equations, we have the WP is equal to 2 alpha RCU times RT theta. So all this derivation equation from 4.1 until to the last one is referring to the rigid scope mechanism. So the 4.7 equation is tend to the internal plastic work dissipated on the scope boundary during these small rotations is calculated as a product of the shear resistance integrated along the circular arc and displacement of the boundary. So the equation 4.6 and 4.7 can be expressed to the failure load in the form of the equations sigma F gamma times T plus Q plus Cu and C, where NC is equal for alpha times R over B power 2. So the next one is that the surface load or ultimate bearing capacity is calculated to find the NC as 4S negative power 2 R sin S. So by differential to the delta NC over delta S equal to 0, this is what the end we have from equation 4.11. So the next 4.11, if we extend it to the assumptions that x equal to 0.191 and we substitute to the equations, we can have that NC is equal to 5.52. As expected, this load is larger than the true collapse load of NC equal to 5.14. Where do we get the 5.14? Is the first NC introduced by the previous slide, number theoretical part, equation 4.1. If you look at here, NC is 5.14. But the deriving equations according to rigid scope mechanism has produced that NC is equal to 5.52. It's quite big compared to we have previously as a 5.14. So the scope mechanism is considerably simpler than the branded mechanism. So the real advantage of the scope mechanism will be accounted and or in two layer strata. I mean that kalau dia punya applications ni untuk single layer, dia tak berapa nampak significant sangat lah. Tapi kalau kata problem kita analyse for the single layer of soil, so you can see how good the rigid scope mechanism is berbanding dengan the first failure mechanism. So how we can have the discussion from the case study, the insufficient bearing capacity, the mostly likely cause of the transcranial grain elevator failure. So the branded mechanism would provide a reasonable good predictions of the bearing capacity if the soil was homogeneous as confirmed by the plate load test, where the failure mechanism was entirely confined to the upper clay layer. So this is the case kalau kita assume failure tu hanya berlaku dekat bahagian atas saja. according to the soil investigation Bolog report. Tapi disebabkan unpredictions on the size of the footing and also the plate load test punya data menyebabkan failure tu sebenarnya dia bukan berlaku pada upper layer tetapi dia berlaku dekat bahagian lower layer juga. So lower layer itulah yang menunjukkan sebenarnya tanah tu has a low shear strength compared to the first shear strength of the soil. So the real mechanism was much deeper due to the large foundation width and penetrated a weaker lower layer. An approximate approach using the Prandtl formula with average shear strength appeared to be neither accurate nor conservative. So dia tak kata dia punya tak bagus ke apa, tapi dia boleh guna untuk certain condition. So in contrast, the upper bound limit analysis using a scope mechanism provided a remarkable good predictions. So just now on the first layer ataupun single layer problem, if you have two layer of soil, for example here, you can see that the failure mechanism has extended to the lower part. So the first layer we call it upper part and then the second layer we call it as a lower part. So just now, apa yang kita andaikan pada first layer ni, failure mechanism ni hanya berlaku dekat bahagian atas saja. Kalau kata kita andaikan failure mechanism tu berlaku dekat bahagian bawah. So you akan nampak analisis tu dia dah tak sama macam mana kita buat analisis untuk single layer. And then if you notice here, the undrained coefficient dia bukan lagi ada single value. It has two value according to the depth dan juga soil type lah. Contohnya kalau upper layer ni dia punya undrained coefficient is a Cu1 mutations. And then kalau slip circle tu masuk dekat lower layer, so dia dah tak sama lah undrained coefficient, dia dah jadi Cu number 2. And then slip circle up to first layer dia dah jadi Cu1. So you can see that the slip circle punya surface tu dia not located only in the first layer. So they also has in the upper and bottom layer. Therefore, to counter the analysis, kita kena consider both layers. Kena bahagian atas kena ambil kira, kena bahagian bawah pun kena ambil kira. So therefore, they come into the analysis yang mana shear strength of the soil ni dia dah adjusted to calculate macam mana the effect of these two layers of soil. For the Prandtl mechanism, it's become very difficult to calculate the failure load and it's even no guarantee that it's going to be the exact solution. So therefore, an approximate solution can be found by weight averaging of the undrained shear strength over the depth B over 2, as you can see here. So the undrained coefficient is equal to Cu1 times M plus dengan Cu2 times 1 minus M equal to Cu1 times M plus N minus M and N. So what is the M? M is a 2D over B and is a Cu2 over Cu1. So now dia dah lebih sesuai lah sebab sekarang ni kita dah nampak slip circle kita sebenarnya dia tak cover untuk upper layer saja, dia cover both. So analysis dah tak boleh ambil first layer Cu sajalah, so kita kena ambil kedua-dua nilai Cu upper dengan lower layer. So macam mana nak counter the effect both Cu tu? So this is the right way lah. Masukkan nilai M, masukkan nilai N, so you boleh nampak lah the modification on the undrained coefficient value. So substitute into equation 1 kita. Equation 1 kita tu yang tadi tu sigma sama dengan gamma darab T plus Q times dengan SC gamma T times Q plus dengan Cu1 and C. So dia masih lagi menggunakan konsep yang sama, the scoop mechanism, dia ada internal plastic work dissipated, kemudian ada some kinds of small rotation on the scoop boundary. So the extended WP to the last equation as shown in the 4.14, and then the equation 4.6 and 4.14 is simplified according to the first or original equations here. So gamma times T plus Q plus Cu1 and C. So what is the NC? NC can be calculated from the equation 4.16, and therefore NC for these two strata soil layer is given here. Maknanya the formula dia dah jadi lebih besar lah sebab nak counter the two effects. So in here you can see that by looking for the most dangerous kinematic mechanism, we shall try to minimize this failure load and approach the true collapse load from above. So because since alpha equal to B over R equal to X, so the equation 4.16 can be rewrite as given in 4.17. So now dia dah counter lah the N, M kat sini adalah weak factor lah untuk consider the effect of two strata. So the equation 4.18 can be resolved numerically with respect to X, so which would correspond to the most dangerous mechanism for specific value of M and N. So for a weaker lower layer, Cu2 less than Cu1 and less in the range 3, so the corresponding value of Nc are given in plot. Maknanya for certain condition, Nc ni dia dah tak boleh ambil sebagai 5.14, tak boleh ambil 5.52, tetapi Nc boleh diguna pakai dengan kaedah rujuk kepada graf yang ni lah. Contohnya kalau you ada ratio antara Cu2, Cu1 ataupun kita panggil dia sebagai N, kemudian you tahu berapa nilai M. M ni apa tadi? M ni kalau kita tengok previously, M sama dengan 2D over B, N sama dengan Cu2 over Cu1. So kita dah boleh dapat nilai Nc yang baru. So nilai Nc yang baru ni bergantunglah kepada nilai N dan juga nilai M. Okay, in summary, there are few analysis and theoretical has been explained just now. For single layer homogeneous soil, the conventional bending capacity formula based on the Brandt failure mechanism provides an exact solutions. Two-layer strata, its approximations using a weight average of shear strength with the depth is not rigorous. So this is where the upper bound limit analysis can provide some useful results using simple kinematic failure mechanism such as the scoop failure mechanism. So now we try to analyze according to the theoretical given just now. This is a problem. We have a mat foundations or rectangular with the size B times L. V kita 23.5, embedded depth T kecil ya, sebenarnya T kecil sama dengan 3.7 meter. This is the problem. Kemudian daripada soil investigation report, dia dah bagi tahu unit weight of the soil is 18.7. The first undrained cohesion, the first layer undrained cohesion is 54 kPa, and then second layer is a 31 kPa. So kalau tengok sini 54 kPa ni actually dia dah quite strong lah undrained cohesion kan. So that's why the previous the past is just assume that single layer analysis pun dah memadai without notice that below that dia ada very weak cohesion 31 kPa pada kedalaman 9.7 meter. So ini yang problem yang mana dia tak dapat detect awal pada fasa construction dan juga pada fasa designing in the last years back ago lah. So these are the model parameters. Geometry ni kita boleh keluarkan lah based on the problem. Width of the rectangular footing sama dengan 23.5. Length of the rectangular footing L sama dengan 59.5 meter. Depth of foundation T sama dengan 3.7 meter. So soil profile. So profile ni daripada Bollock report. Thickness of the upper clay layer below the footing D is a 6 meter. So ini yang dia explainkan. Undrained shear strength of the upper layer. Cu ni adalah undrained shear strength. Kalau kata Bollock report you bagi unconfined compressive strength iaitu Qu, nak dapatkan undrained shear strength you kena bahagi dengan 2. So you have to be careful lah kalau you ada Bollock ataupun soil report, you kena tengok adakah dia dah straightforward bagi you undrained shear strength ataupun dia bagi pada awak undrained compressive strength. So undrained compressive strength is a Qu, nak dapat Cu you kena bahagi dengan 2. So undrained shear strength of the lower layer 31 kPa. So unit weight of the soil is 18.7. So loading surface surcharge load Q sama dengan kosong, maknanya dia tak ada surcharge lah on ground surface. Failure contact pressure from the plate load test sigma F is 400 kPa. Yang ni yang dia measured from the plate load test. The true contact pressure at failure is 293. So kita nak tengok lah yang kita calculate ni dia dekat dalam range mana, 400 kPa ke ataupun 293. Tetapi yang accounted from the site report, the true contact pressure adalah 293. So bila dia buat plate load test 400 kPa, seolah-olah safe lah kan. Tapi sebenarnya bila analysis without considering the effect to strata ke, dia dah jadi berlainan lah. Okay, we go for the first one. We assume that the analysis being carried out on the single layer soil ataupun homogeneous. So for the homogeneous, we can have that the NC sama dengan 5.14. Kemudian shape correction factor, so kita boleh pakai lah equation 4.3. Depth correction factor pun kita boleh pakai equation 4.4. So we have the value SC 0.08, DC sama dengan 0.06. Kemudian bila dia buat calculations, from the analysis, it was found that the sigma F sama dengan 386 surface load, iaitu close to 400 kPa. However, the significant higher than the true failure pressure at the 293. Maknanya yang dia calculated tu sebenarnya lebih tinggi daripada yang berlaku pada site. So 386. Maknanya analisis ni konservatif lah. Dia not indicates the real failure of the site. Okay, the other way is that kalau kata kita menggunakan kaedah conservative analysis, okay, for conservative estimate, let's say that we analyze it in the first one as the first layer CU is 54 kPa and then the second layer CU is 31 kPa. If the soil was homogeneous but with the properties of the weaker lower layer counter in to the analysis, therefore we can have that the surface failure load is equal to 251 kPa. So how do we get 251 kPa here? 69.2 ni benda yang kita dapat tadi lah daripada calculation, iaitu gamma darab dengan T. Gamma kita 18.7, darab dengan T 3.7, so you akan dapat dalam 69.2 lah. Kalau you tekan calculator, you akan dapat the answer is 18.7 times dengan 3.7, so you can have 69.2. So ini kita constant. Yang sekarang ni kita nak tengok the effect of the undrained question lah. Undrained question ni dia tunjuk kalau kata dia ambil very weak, where the weakest undrained question 31. 54 ni memang sure lah safe kan. So kalau kata dia ambil 31, nilai CU dia tu pada weak layer, and then 5.14 ni is something that constant that we have from the first one here. Therefore, the surface load is equal to 251 kPa. So 1.14 ni dia dapat dari mana? 1.14 ni dia coming from this one lah. CU NC darab dengan 1 plus SC plus dengan DC. So itulah dia dapat 1.14. So apa yang berlaku is that the calculations is safe. Maknanya 251 kPa ni lebih kecil daripada true collapse failure 293. Tapi the predicted value is only 20% more conservative than the true failure pressure, which is 293 kPa. So kalau tengok dia punya range agak besar sangat lah kan. And that's why it is called as a conservative estimate. Maknanya dia ambil weaker cohesion dengan some assumptions that NC at phi sama dengan 0. So this value is 251. So nampaklah dia punya calculation safe because it's less than 293. But how kalau kata kita analyze in the two layer strata? So just now masih lagi consider as the single layer. So now kalau you nak analyze as a two layer strata with the effect of different CU upper layer and lower layer, we can see that right now kita kena masuk weight factor lah. Weight factor M, weight factor N. So weight factor M dengan N ni dah kira awal lah. Maknanya the M kita akan dapat 0.51, N sama dengan 0.57. M tu sama dengan 2D darab B, N sama dengan CU2 bagi dengan CU1 daripada equation 4.13. This we call it as a approximate method based on the blended solution using the weight average of the undrained strand, modify CU for both layers NC and. So maksudnya dekat sini, dia menggunakan pakai NC yang sama 5.14, tetapi nilai CU tu je yang berubah. So dia tadi kita ada failure mechanism dua kan, satu blended, satu lagi scoop. So now dia nak analyze two layer strata menggunakan blended failure mechanism. So dia nak tengok apa surface load yang kita dapat. So daripada assumptions ni, kalau dia menggunakan blended failure mechanism dengan modifications for the CU according to the ratio M dengan N, it found that the modified or adjusted undrained coefficient is equal to 43 kPa lah. So nilai CU dia dah jadi 43 kPa. So dia tak pakai 54, dia tak pakai 31. So 43 kPa ni lah yang dia akan straightforward guna dalam equation sigma F tadi. So 69.2 gamma darab T campur dengan CU and C times dengan CU and C times dengan shape factor dan juga depth factor. So dalam kes ni, you akan nampak kalau tadi single layer dia pakai 31 untuk very weak undrained coefficient. But now 54 pun dia tak ambil, 31 pun dia tak ambil, tapi dia ambil yang tadi adjusted ataupun modified. So therefore, the adjusted or modified CU 43 kat sini bring to the final surface load is 321 kPa. 321 kPa ni lebih lagi besar daripada the true collapse of the soil. The true collapse of the soil 293 saja, which is 10% larger daripada yang berlaku sebenarnya. So an approximate solution can be found by this way lah. Apa yang dia boleh concludekan, the primary solution for a homogeneous soil is the exact solution, but not in the two layer strata. So it is observed that it is not only inaccurate, but it also not conservative and could lead to failure. So ini antara kenapa untuk two layer strata, untuk primary failure mechanism dia tak sesuai. Therefore, you have to choose or you need to go to the second failure mechanism, iaitu scoop failure mechanism. Okay, untuk failure mechanism ni, apa yang kita dapati adalah nilai NC dia. Nilai NC kita dah tak pakai 5.14, nilai NC dia kita kena dapat daripada graf. So nilai NC yang kita dapat daripada graf ni, kalau ikutkan NCU2 over CU1 iaitu N, kemudian M ni dalam this ratio juga. So M kita 0.51, N sama dengan 0.57. So daripada this graph, NC sama dengan 3.7. So apa yang berlaku? Here you can see that the calculation surface load ni, dia akan pakai NC sama dengan 3.7. So dia dah ganti dekat sini. And then CU, dia tak payah ambil pada weak layer. Dia just ambil at the first undrained coefficient strong layer saja. Maknanya first layer undrained coefficient iaitu 54 kPa. Kenapa kita guna 54 kPa instead of 31? Because the 54 kPa ni is the true ataupun the true failure mechanism that assuming occur in the first layer with consideration the NC has been corrected according to this ratio N dan juga ratio M. So apa yang dia dapat daripada this analysis, so the value is the 297. So 297 a bit close to dengan 293 lah. Maknanya dia lebih sesuai dan lebih give the right answer lah, instead of you menggunakan the other first primary failure mechanism untuk problem two layer soil strata. And the next one is mitigations and mitigation measures. So mitigation measures ni selalunya dia akan masuk dalam this part of the conclusions lah. Selepas kita dah buat analysis, kita akan produce ataupun kita bagi suggestion, recommendation apa yang boleh diambil untuk overcome ataupun prevent any future failure. For example here, propose mitigation measures related to the foundation failure. Okay, the first one, untuk this kind of the problem, transcontinental grain elevator, so apa yang dia cadangkan adalah emptying the elevator. So it was the priority to save the bit lah, maknanya asal tujuan bin tu untuk dia simpan gandum lah. So tapi dia salah estimate untuk bearing capacity. So bila dia memasukkan gandum, by the time days tu tiba-tiba footing dia fail. So it was dangerous operation. So the grain below the ground level was removed to the deep trench dug at the north side using existing underground conveyor tunnels. In spite of the difficulty and danger of this operation, all was successfully saved in the less than 3 weeks. So ini yang pada ketika tu apa yang mereka buat untuk overcome from worsen failure of bearing capacity. Maknanya antara kaedahnya dia itulah dia kosongkan section yang selamat lagi lah. The next one is the underpinning of the workhouse. So the next step was underpinning the workhouse throughout, as it was feared that it may become unstable as well. So this was achieved by sinking a 1.5 diameter pier under each of the 24 columns of the building. Because of the heavy loads, the height of the structure and its small base, so it was necessary to reinforce the foundation and the structure before underpinning operation could begin. So this is the importance repairing work yang mana dipanggil sebagai underpinning, iaitu reinforced by having additional structure. So this was achieved by sinking 21.2 meter diameter piers outside the building walls and constructing a framework of wooden pushers. So a truss arrangement was formed, allowing for a larger part of the building to be temporarily transferred to the external piers. So after this, the access tunnels were excavated under the foundation mat and 2 meter diameter piers were sunk down to rock under each of the internal columns. So the 1.5 meter diameter piers were sunk under the wall columns and the building load was transferred to the new foundations. So the work was completed by June 1914. So if you look at to the original plan of the building, so ada certain area tu fail, but some the affected section tu masih boleh buat repairing work. So the repairing work for this building affected tu dengan cara dia masukkan additional reinforced structure. So the process successfully occurred and completed in the June 1914. So strengthening of the bean house. The works of strengthen and underpin the bean house started in February 1994. It was decided not to return to original elevation but just to bring it above the groundwater level. So it explained here macam mana dia buat the strengthening of the bean house. So a row of 14 2.1 meter diameter piers below the lower end of the foundation slab was sunk to the rock and concreted. As the under excavation on the east side commenced, the building began to rotate around the piers, assisted by the row of the pushers of the west side. For additional rows, each of the 14 2.1 meter diameter piers were sunk to the rock level. As the building continued to get strengthened by excavating of the higher side, the center of rotation was first shifted to the second pier row on the lower side, and then the central row. The jacking screw were then placed at the few western pillars and helped to control further rotation by pushing the western side of the building up. All these statements were reported in the case study and presented again accordingly what they have carried out during the time. So ini gambar-gambar yang merujuk kepada under excavation activity for repairing work, and then juga checking up on the west sides and the cross sections with the piers, the screw checking units. So a bit complicated jugalah dia punya repairing activity here, sebab kalau ikut betul-betul ni kita nak kena pasang instrument, monitoring instrument, kemudian some monitoring tu untuk check lah sama ada our building tu acting like what we expected ataupun they acting beyond our expectations lah. But as reported, the work was successfully carried out. Okay, the lesson learned, what we can have from here is that how important the site investigation. Dalam mana-mana geotechnical applications, kalau kata you tak ada bolok report, you tak ada SI report, it's better to have the one lah. Sebab site investigation ni very important, giving you the explanations, contohnya the purpose of work, kemudian daripada site investigation tu kita akan ada bolok report. Daripada bolok report ni dia mostly tell you lah the soil properties, sama ada index parameter ataupun dipanggil sebagai mechanical parameters. Selalunya yang paling penting dalam geotechnical application tu adalah mechanical parameters. Mechanical parameters contohnya cohesion, contohnya internal friction angle. Kalau dia melibatkan excavation ataupun you want to construct a road on the soft soil ataupun road tu nanti kita akan ada trial embankment. So the trial embankment will be placed on the soft soil. So dalam kes ni the most important parameter adalah odometer parameter ataupun kita panggil consolidation parameter. Consolidation parameter ni dia boleh dapat daripada odometer test. So odometer test ni dia complementary kepada shear strength parameters. So kalau you boleh carry out for the shear strength parameter, if the case of the constructions on the soft soil, so better ada sekali set one dimensional testing punya results lah. Daripada situ kita boleh dapat dia punya compression index, kemudian kita boleh tahu pre-consolidation pressure, kita boleh tahu OCR. OCR ni pun is a ratio that telling you sama ada you punya soft clay tu dia dah achieve to the strength required ataupun not achieve to the strength what we looking for. So from this problem untuk transgranular grain elevator is stated that the main lesson is the importance of the proper geotechnical site investigation. So the fact the other similar heavy structure in the area were founded on similar foundations did not help. Maknanya they just rely on the past report by other buildings, kemudian they're not checking on the building footing size. So they rely on the report orang lain, tapi dia tak tengok pula design foundation tu sama tak sama dengan design foundation untuk building dia. So dia consider kalau bangunan sebelah tu selamat, so dia punya future bangunan pun selamat lah. So ini yang tu dia punya assumption yang diceritakan dalam this case study. So what they found that after failure tu dah berlaku, baru dia ambil initiative nak buat site investigation, dan surprisingly they found that a locally weaker clay layer located below the typical stiff clay layer mess up all the analysis. Maknanya barulah dia perasan punya yang dia nampak kat bahagian atas tu memanglah kuat, tapi sebenarnya kat bahagian bawah tu itu yang punca kepada masalah sebenarnya. Field load test. Field load test ni kalau you pakai foundation, shallow foundation je cukuplah melalui ataupun madai you buat plate loading test. Tapi kalau you punya foundation tu require untuk sampai deep foundation, so you kena buat pilot test lah, plate loading test dah tak sesuai. So dalam kes ni, bila dia guna pakai field plate load test ni, dia punya limitation adalah plate load test size lah. Sebabnya kalau you tengok sini, this happen due to the scale effect. So the small size of the plates compared to the foundation did not allow for the deeper weak clay layer to be involved in the failure mechanism during the test. So conclusions, in order to able to make meaningful predictions based on the field load test, these tests have to be performed at the real 1-to-1 scale or different elevation, which is an involved and expensive operations. So kalau siapa pernah buat plate load test, tahulah kan dia punya size plate loading, plate size tu berapa. So dia mungkin lah kita kena buat scaling down kan. Kalau kata footing kita lagi besar daripada plate size tu, so you may expect what should be predicted lah daripada plate result dengan yang you nak cari sebenarnya. So dalam kes ni yang itulah berlaku. Limitation of the plate size tu, dia bagi prediction sehingga first layer saja. Dia tak predict sampai the weak layer ataupun dekat second layer yang mana strength dia 31 kPa saja. Itu salah satu causes to the problem lah. Okay, ini salah satu testing lah, static load test. So, okay.
Load test may be carried out in the following 3 load configurations: axial compression, axial tension, and lateral. Here, the procedure of a static pile load test with axial compression loading is explained. First, the test pile is installed into ground. A heavy bearing plate is placed on the pile to ensure uniform load transformation. One or multiple hydraulic jacks are installed to apply loads. The hydraulic pump is piped to the hydraulic jack. Applied load can be monitored through strain gauges on the pile or hydraulic pressure. Here, a wireless pressure sensor is installed on the pressure port of the hydraulic pump to monitor load application. Then, the load beam is placed on top of another bearing plate over the hydraulic jack to react against load. The load beam is adjusted to be centered and level to ensure uniform load on the pile. Load transfer beams are placed on both ends to hold the load beam down and supported by 4 or multiple reaction piles that are fixed to the ground. For deflection measurement, 2 reference beams are installed around the test pile with enough clearance distance. Multiple wireless dial indicators are used to measure movement of the testing pile. Align and mount the indicators parallel to the pile. Turn on all the measurement devices and connect them in the Motionix wireless pile load test software on iPad via Bluetooth. Once connected, readings are shown remotely on the iPad in real time. Zero all readings in the app to start the test. Start the test by applying the load through hydraulic system based on the test standard procedure and let the app automatically record all devices' readings. Test results are seamlessly recorded and documented automatically. The same instruments can be used for axial tension and lateral load configurations. However, the test setup and loading structure would be different for each case. Thanks for watching.
Okay, ini salah satu contoh lah pilot test. Sepatutnya dia lebih sesuai kepada plate load test lah, tapi saya tak tunjuk kat sini. I hope that you have some few times untuk carilah what's informations comparison lah. Plate load test, macam mana buat dia. Pilot test tadi saya dah tunjuk lah. Pilot test ni ada static, ada dynamic. Okay, next lesson learn yang boleh dapat daripada transcontinental grain elevator ni adalah conservative design. So conservative design ni, kalau kita pakai conventional theoretical Suzuki formula based on dependent mechanism provides the exact solutions for undrained bearing capacity of homogeneous soil. Maknanya dia okey, dia tak ada masalah. Tapi untuk two layer strata application, this formula with average strength may not necessarily be conservative. So in this case, conservative prediction may be achieved by assuming that the soil is homogeneous with the undrained strength of the weaker layer. So these four may lead to an over conservative and too expensive design. So dia tak sesuai pula lah. Apa yang sesuai untuk kes yang two layer strata adalah menggunakan kaedah upper bound limit analysis. So it's using a simple kinematic mechanism which provide useful tool determining an upper bound for bearing capacity foundation on the layered strata. So thought the obtained prediction is not conservative. In some cases, it may be pretty close to the true failure load. So kalau kata you having a problem and then you want to estimate the bearing capacity of the soil, the first of all you kena check dululah you punya SI report. SI report ke, kalau dia tak ada SI report, cuba tengok daripada gambar yang dia tunjuk apa investigations profile about the soil layer. For example here, yang ni saya kira kata bagi some sedikit explanation lah berkaitan dengan your punya assignment satu kan. Contohnya ini your punya informations. So you nak tahu information sebab ada setengah problem tu dia just bagi image kan. Daripada image ni kita kena keluarkan sendiri berapa nilai CU. Kalau problem you nak analyse single layer, berapa yang you dapat. Kalau you analyse untuk double layer ataupun strata layer, so you can see, you boleh buat perbandingan mana yang lebih sesuai, analisis single layer ke analisis dua layer. So you can choose the undrained coefficient, the parameter of the soil according to the SI report. So maknanya kalau semua maklumat tu bagi pada awak, no one information you boleh exclude daripada analisis lah. You kena include sekali. Kalau dia ada water table effect ke, kemudian dia ada some factors selalunya water pressure effect, ground water table effect ni memang tak boleh lari lah dalam bearing capacity ataupun the profile of site investigations on this kind of problem example. Maknanya you kena tengok lah apa semua information because geotechnical ni is very complex data. Maknanya one single data dia tak boleh bagi the final predictions. So you have to mix around, tengok kesesuaian dia, teori mana yang sesuai dan analisis mana yang sesuai. So macam conclusion tadilah, kalau kita guna tersegi for single layer je maybe sesuai, tapi kalau problem you melibatkan dua layer lah lebih sesuai. Tapi kaedah yang mana, failure mechanism yang mana nak pakai, through scope mechanism ke atau yang biasa pakai blended mechanism. So your justifications is important to stand on your analysis carry out. Kalau you dah buat analisis macam tu, mesti ada sebabkan you pilih analisis tu. Itulah yang you kena jawab dalam you punya assignment satu. Assignment satu ke, assignment dua ke, lebih kurang sama. Cuma case yang berbeza. Contohnya assignment satu awak lebih kepada bearing capacity, assignment dua awak mungkin lebih kepada slope failure. So pusing-pusing kat situ jugalah. Dia punya kaedah nak menjawab, nak tulis report sama, you kena ambil skill ataupun teknik forensic investigation. So you kena tahulah daripada introductions, problem statement, causes of the failure ataupun causes of the problem, and then you propose the solutions. Sebelum nak propose solution, you kena take out lah the information, geotechnical informations ke, structural informations ke. Kemudian apa analisis dia, teori apa yang you nak pakai. Daripada teori, you dah tahu analisis dia. Daripada analisis tu, you buat calculation. Daripada calculation tu, you conclude kepada design ataupun apa yang you dah jumpa. So daripada situ, you buat pula recommendations on the mitigations, and finally apa yang you boleh dapat ataupun lesson learned from this case study presented ataupun on your reported assignment. So do you have any more questions?
Doktor, nak tanya, kalau yang bearing capacity factor, bukan, shape correction, shape correction factor untuk circle, guna, kalau yang square guna 0.2 B bahagi L kan, divide L kan. So kalau formula untuk circle,
yang tu you kena tengok. Kalau dalam biasa undergraduate kita refer Hansen dengan Meyerhoff tau. Kalau circle, circle kan dia punya diameter circle kan kita boleh consider as a B as well, right? Ya. So, saya buat satu contoh. Nampak tak? Okay. Ini kita punya foundations strip ataupun rectangular as a B lah. So, kalau dia circle, diameter dia tu adalah B juga. Ni diameter of the circle, footing. So this diameter also can be considered as a B. So dia tak ada masalah lah, you can use the formula shape factor yang dah bagi dalam nota ni lah. Iaitu 0.2 B bagi dengan L. Kalau kata circular diameter dia 10, 10 bagi L lah. Boleh tak?
okay doktor? Boleh.
Itulah maksud saya. V lebar dia tu sama dengan diameter of the circle footing. Dalam kes ni kan, kalau macam you tengok untuk postgraduate, dia pakai single teori saja. Tapi kalau undergraduate untuk include shape factor, ada Hansen, ada Meyerhoff, lagi banyak teori kan. Tapi dalam kes ni, you just use this one, I think that's enough. Tak perlulah nak buka sampai yang lagi detail-detail kan, macam Hansen, Meyerhoff tu lagi. Sekali lagi dia ada inclination factor, loading. Sekarang ni kita assume loading kita vertically tau. Tapi kalau you ada some intention nak tahu lebih kan, tiba-tiba tercarilah shape factor untuk Hansen ke Meyerhoff, you akan nampak lah, maknanya setiap researcher ni dia try to produce their own punya formula. So Hansen mungkin produce shape factor lain, Meyerhoff mungkin produce shape factor lain, tapi this kind of the thing yang mana stated by Lang 2007, I think that is enough to follow lah, more easier lah, because whatever shape of the footing, sama ada straight ke circular ke, we can use this one 0.2 times B over L. The thing is that you need to know B tu apa, L tu apa, and T over B tu apa. Sebab kalau Hansen Meyerhoff dia tak guna T, selalunya dia guna D, embedded depth. Kat situ lah. Tapi sikit je, sama je. Lagi tak? Okay, minggu depan kita akan masuk chapter belum lagi chapter. Minggu depan kita akan masuk satu lagi kes baru. Dia kes kepada bearing capacity juga. So I think that for that one, we try to cover next week lah untuk topik yang tu. So try lah buat dulu learning activity untuk this week 7 dan juga week 8. Cuba tengok nota yang saya ada. Kadang this semester saya upgrade lah, saya lambat upload. Untuk yang nota malam ni dengan 2 minggu sudah tu saya dah upload lah. So this kind I mean that kalau you have different cases, dia punya flow proses sama. Tapi you nak bawa keluar root of causes ke, you nak bawa keluar mitigation ke, you nak dapatkan lesson learn ke, mungkin dia tak sama lah. So maknanya kita boleh bagi assignment tu macam-macam berbeza cases. Tapi cara menjawab tu lebih kurang sama je. So kalau kata di semester you cari kawan awak balik, semester lepas tu mungkin dah tak sama case dia. Tapi kalau kata you nak tengok dia punya flow, cara menulis report tu boleh lah kan. But the calculation, the analysis totally not same because problem dah tak sama. So I mean that itulah yang apa kata the structure of the course. Kalau you tengok kita cover all the geotechnical aspect, slope stability, bearing capacity, settlement, kemudian excavation, and then next is tunneling. Kalau you tengok macam sebelum chapter 3 ni adalah chapter 2 kan, settlement. Settlement sebenarnya kalau dalam bearing capacity pun dia takkan lari. You cerita bearing capacity, dia mesti resulted to settlement. Sebabnya bila ada bearing capacity, mesti ada berlakunya reducing in the height. So you kena tahulah settlement dia berapa kan. Dalam this case, kalau kata case study yang you pilih tu tak ada information about settlement. Tapi dia bagi bolok report consolidation index, dia bagi any other things data. So you boleh calculate settlement as well. So maknanya the problem untuk geotechnical ni dia bukan problem yang asing-asing. Dia boleh satu masalah dia boleh kait antara satu sama lain because we study on the soil behavior. So the soil behavior can be factorized by many factors lah. Variables dia banyak. Factors dia pun banyak. So mostly loading, lepas tu water table, surcharge tu antara benda-benda faktor yang diambil kira lah. Kalau kata you study on for the experimental, dia akan tengok pula confining pressure, dia akan tengok strain applied. Kalau you tengok pula loading, adakah static loading ataupun dynamic loading. So dia banyak. So that's why geotechnical ni you have to, I mean that takes time sikit lah untuk nak faham kan kalau betul-betul dah tinggal lama. Kalau you think that there's no much time, you just can rely on the notes given pun dah memadai lah. But dia punya limitations, you only focus on that one case study lah. You dah tak boleh, you kira kata pemahaman tu berdasarkan pada satu case study. Kalau you nak test your understanding tu dah cukup tak cukup, strong ke tak strong fundamental, you cuba tengok case study yang bearing capacity failure, boleh tak you faham dan you keluarkan balik macam mana yang presented by the article, by the researchers ataupun authors from the article. Kalau you boleh keluarkan yang sama pemahaman, maknanya you are in the right path and in the right way lah. So datanglah case study macam mana pun, you can carry out the forensic investigation. Itu yang penting sebenarnya. Okay. Okay, untuk case study seterusnya minggu depan, kita try cover minggu depan saja. Boleh? Saya rasa awak dah boleh jawab assignment 1. Saya agak lambat lah, saya pun tak tahulah due date assignment 1 awak submit bila. Tapi rasanya once this chapter finish, I think that you have time untuk buat report assignment 1 lah. Untuk makluman awak, this course ataupun master program ni kita benarkan you submit, macam kalau kata first submission tu tak fulfill ke pada rubrik ataupun standards, dia ada chance untuk you buat corrections lah. So you jangan macam kalau you rasa macam dia kurang nak kena betulkan, ataupun tiba-tiba Dr. Ong Kat Shen bagi kebenaran untuk buat correction amendment. So take the opportunity untuk buat corrections. Because opportunity tu dia bukan buka sepanjang semester kan, tiba-tiba dia nak tutup dah lah kan, sebabnya tutup nak masuk assignment lain kan. So dia tak boleh buka sampai sepanjang semester. Kalau dia rasa macam okay, assignment you tak sampai standard rubrik yang kita bagi kan, so kita return balik, so you buat lah. Sebabnya for me penting lah, because dia punya requirement untuk lulus kena dapat B kan. Betul tak? Setiap course tu kena dapat B. Dapat B minus. Kalau dapat B minus tu kita fail lah kan. So ambil peluang lah. Satu lagi dia tak ada exam. So pulen lah, lebih baik lah bagi goreng sampai Bangit lah kan, sampai cukup lah. Kalau ikut rubrik tu nampak kan, nampak kemas kan. Kalau you nak ambil contoh senior SEM lepas, boleh lah tengok macam mana dia punya reporting, apa structure assignment kan. Tapi the content mungkin tak boleh pakai sebenarnya, macam saya katalah case study mungkin berbeza. The techniques, the skill, the process sama.
Dapat contoh tak example format student yang sebelum ni?
Saya kalau untuk you punya macam tu you nak refer untuk copy you, I think that better you tanya owner tu sendirilah kat mana kan, ataupun disimpan kan. Sebab saya pun nak kena, saya tak tahu bendanya di mana, kena minta permission. Kalau dia pun kata okey kan. Tapi selalunya kalau you boleh jawab ikut format tu cantik lah. Selalu yang kita orang perasan kan, dia jadi macam report, business report dengan academic, dia macam business report versus academic report. Macam tu lah. Kalau business report selalunya short and precise lah. I think that yang tu selalunya kan. Dia less words tapi figures a lot. But this time untuk yang macam technical report ke academic report ni, dia kena ada words explanations, dia kena ada introductions. Kalau you boleh masukkan problem statement lagi cantik. Kemudian you masukkan theoretical background, you masukkan analysis, you masukkan calculation sikit, you masukkan conclusion, mitigations, lessons learned. Maknanya dia cukup padat, okey. Selalunya yang jadi return balik tu sebab yang tu lah kan, mungkin first submission tu style dia tak ada, style untuk menjawab for academic report. Tapi dah second time dah mungkin dah dapat input kan, barulah kena kan. So yang tu yang terbaik lah. Of course not the first one is always right. So you can have the opportunity, chance untuk buat corrections. It depend to the situations lah. Kalau the term correction okay, accept je, so okay lah. Tapi nanti end up makalah tak best kan. So mungkin you can personally ask the question, what's the best reports, can you produce apa framework dia kan. Sometimes the thing is that you come close to him or you just ask from your senior in the second SEM. Maksudnya apa ni, Puan Azura boleh minta dekat Pak Tam mesti ada report tu. So kalau Pak Tam okey lah.
Okey, nanti saya cuba.
Selalunya yang tu lah dia.
Okey je.
Okey kan? Betul, sebab saya nak bagi pun saya rasa kena minta permission. Saya pun I think that the thing, the owner tu lah kena, dia kata okey. Kalau saya pun tak boleh nak say no lah kan. Alright, so next week kita masuk new case study untuk masih lagi bearing capacity tapi problem yang berbeza. Okay, this is a bit easy lah berbanding yang akan datang lagi. So I hope that you can understand and capture the theoretical background of this one. Kalau dalam branches civil engineering ni, geotechnics ni something that saya rasa not really people get into it lah. The people who may like this one, secara surface tu yes, tapi yang betul-betul facing it ataupun experiencing it, so agak sikit lah. Kecuali you memang terpaksa, memang dah tak ada, memang you akan belajar. So kalau kata nak saja-saja and then you ada pilihan, kebanyakan orang tak pilih geoteknik. Macam tu lah. Okay, saya rasa kita habis kat sini dulu. Terima kasih atas komitmen anda, giving your time to attend this online lecture. I pun tak tahulah sejauh mana you faham tak faham, but once you can submit the report, I hope that you faham lah kan. Sebab macam mana pun nanti you refer kat sini juga. Sebab kita nak tengok dia punya proses flow untuk forensic investigation lah. The part is that theoretical tadi tu lah, you nak analyse as a single layer ke, you nak analyse as a double layer, two layer strata. Kalau two layer strata, you nak consider failure mechanism macam mana. adakah the conservative one ataupun you nak ambil yang very good one as a scope failure mechanism. Kalau you dah buat two calculations, branded dan juga scope mechanism, and then you need to justify lah yang mana yang lebih baik. So based on the input data from the soil parameters. So I think that's end for tonight, and thank you dan juga Assalamualaikum.
Terima kasih Doktor.
Ya.
Waalaikumsalam.
Nice weekend, everyone.
Terima kasih Doktor.
Thank you, Doktor.